All right, guys. So this will be the last lesson for our unit here, which is geometric probability. Next week we will have our test. So Monday we're going to have a review type ordeal, and then Tuesday we are going to have our test. All right. So just kind of giving you a heads up for next week's. But we're going to go ahead and finish up this unit here. Let's go ahead and jump into it here. So geometric probability. So some essential understanding that you'll need to know. You can use geometric models to solve certain type of probability problems here. In geometric probability, points on a segment or in a region of a plane represent outcomes. The geometric probability of an event is a ratio that involves geometric measures such as length or area. So a key concept here with probability and length. Point S on AD is chosen at random. The probability that S is on BC is the ratio of the length of BC to the length of AD. So again, like we've kind of been learning here, it's always going to end up being the part over the whole. All right, so what's the distance from BC over the entire distance that it could be on, which is from A to D? So part over whole, and I'll show you how that's going to look here with actual numbers. All right, so using segments to find probability. Example 1, point K is on ST, is chosen at random. What is the probability that K lies on QR here? So again, part over whole. So we're trying to find the length here. Let me write this down. The length of QR. So length of QR over ST. All right. So the best way that we can find that here is to go big minus small. So just from QR alone, the big one is 8, the small one is 5. So again, that distance would be 8 minus 5. Over the big distance, or the whole part there, so the whole line goes from 14 to 2. So we would do 14 minus 2. So 8 minus 5 is 3. 14 minus 2 is 12. And we can reduce that fraction of 3 over 12. That would give us 1 over 4. So our probability of it landing between S and T is a 1 in 4 chance. Okay. So again, part over whole, do the big number minus the small number every time for both the part and the whole part. Okay. Example 2, using segments to find probability. A commuter train runs every 25 minutes here. If a commuter arrives at the station at a random time, what is the probability that the commuter will have to wait at least 10 minutes for the train here? So again, we're going to assume that a stop takes very little time. All right, so first step, let's draw a line here. So again, we're going to draw a little line from A to B. All right, so A is going to be 0, and B is 25. All right, and we also have 5, 10, 15, and 20 if we go on 5-minute intervals, right? So the length of the entire segment is going to represent the amount of time between trains there. So a commuter will have to wait at least 10 minutes. That's what it tells us in our part right there, that they have to wait at least 10 minutes there. So if the commuter arrives at any time between 0 and 15 minutes, because 15 would have to be the latest they arrive if they have to wait 10 minutes for the train, right? So we know that the latest they would have to be there is from 0 all the way to 15. So between these 2 points here. That's the part. The part tells us that they have to wait at least 10 minutes for the train. If they're not there within that 10 minutes, then they're not going to be able to get on the train. So anywhere from that range fits in there. All right. So the part that we're looking for is that 0 to 15 range. If that's the case, then that tells me that we're going to do part over the whole part. So the part would be 15 minus 0 over the whole part, which is 25 minus 0. So again, that ends up reducing down to 15 over 25. And again, this fraction also reduces down to 3 over 5. So the probability that it has to wait, it would be a 3 to 5 chance. Or if we did that in terms of a percent, it'd be a 60% chance. That'd be our percentage there. 3 over 5, 60%, all kind of the same thing there. All right. Probability in area. When the point of a region represent equally likely outcomes, you can find probabilities by comparing the areas. So again, if point S is in the region of R, is chosen at random. The probability that S is in region N is the ratio of the area region N to the area region R. So the same thing here, part over whole. We want the part to be in N, but R is the whole part there because N is in R. Okay, so part over whole. A circle is inscribed in a square. Point Q in the square is chosen at random. What is the probability that Q lies in the shaded region? So again, if the circle is on the inside of the square here, then what we have to do is find the area of the circle first, and then find the area of the square and subtract, right? Because that will tell us what part of the square is not part of the circle. So knowing that this side here on this square is a 6. If you noticed here, in a square, all sides are going to be equal. That means that this side will also be, this side will also be 6 centimeters. Now, that line that we just wrote 6 centimeters on is also going to end up being the diameter of that circle. Unfortunately, for area of a circle, we do not need the diameter. We need the radius. So to find the radius here, we're going to end up taking half of that. So the half of our diameter here, that means the radius should be 3. So using our radius here, now we can find the area of the circle. The area of the circle is going to be A equals pi 3 squared. 3 squared is 9, so the area should be 9 pi. Okay. Knowing that our area of the circle is 9 pi, now we're going to go ahead and find the square here. So the square is going to just end up being the area of a square. It's just base times side or side squared. So it'd be 6 squared, which would be 36. So we know that the square is 36, and we know the circle is 9 pi. So to find out the part over the whole that it lands in the circle, the part is our circle here. So since the part's the circle, it's going to be 36 minus 9 pi. Again, that will give us the parts of the square that is not involved with the circle. Over the whole entire part there, which is the square, which is going to be over 36. So again, you just type that into your calculator, 36 minus 9 pi, all divided by 36. And it should come out to be a close number here, right around 0.215. 0.215. Okay. All right, we got one more example to look at here. Last example. Using area to find probability here. All right, so an archery target has 5 colored zones formed by concentric circles. That just means circles that kind of build on top of each other. The circle's diameter is 122 centimeters. So the entire thing across is 122 centimeters. The radius in the yellows of the yellow zone is 12.2 centimeters. So from the yellow zone, from the center to the yellow zone is 12.2 centimeters. The width of each other zone is also 12.2 centimeters. So that means as you continue building out there, right, then that means you're just going to continue adding 12.2 on. So from that center over to the red would be 12.2 plus 12.2. If you went out to the blue, then you'd be 12.2 times 3 and so forth. If an arrow hits the target at a random point, what is the probability that it hits the red zone? So again, our part here is going to be the area from the center all the way out to the red there. So from the red circle in, it has to hit the red zone, right? So what we would have to do is find the area of the entire circle and then subtract the yellow circle away from it. That's how we're going to find our part of just the red zone. That's what it wants there. So to find the area of the entire circle from the red out, right, that's going to be our formula of A equals pi r squared. So the radius, as we know, is going to end up being 12.2 times 2. Because, again, we're going from the center to the red. So that's 12.2s. So 12.2 plus 12.2 is going to end up being 24.4. And, again, that's going to be squared because it's pi r squared. All right? And then we're going to subtract that minus the yellow zone because we don't want the yellow zone involved with that. So that's the entire thing there from the red and the yellow. And then we're going to subtract the smaller yellow part out there, which is pi 12.2 squared. Okay. Over the whole thing there. So that's our part. Over the whole thing there would be, since our diameter of the entire archery thing is 122, the radius for that is going to end up being 61. So that one's going to be pi 61 squared. All we have to do here, guys, is just literally type this into our calculator here. I'm not expecting you to write this all out. Just type it in your calculator as you see it. So pi times 24.4 parentheses squared minus pi and so forth. Write it out. And again, this should give you a decimal as this is simplified here. So once you've typed it in and simplified it out, your answer here should be 0.12. Right around there. Which, again, if they're asking for that in a percentage, it would be right around 12%. Okay. All right. So just to give you guys a heads up, we will have homework over this. It's going to be due by April 3rd, which is our tomorrow for you guys. Virtual office hours, same time. Remember, Thursday will be the last day for virtual office hours this week. If you have any questions, remind me, email me, get in touch with me. I'll find a way to get back in touch with you. And then I'm here for you guys if you need anything. Come through virtual office hours, guys. If you have questions, I'll be here for you, all right? All right, guys. You stay safe and have a great weekend.